So our problem statement is that we want to create a function that draws an isosceles triangle centered around x equals 25 and has a height of 500. We're going to have our x range therefore be from x equals 0 to x equals 50. Again, the center at 25. We can think of the piece of the triangle that we're drawing as being two different lines. And lines are defined as y equals our slope times x plus our y-intercept. So we effectively need to know what this equation is for both of those two lines, and then combine them together into a single function. M, our slope, is defined as our rise over our run. So we know our triangle is 500 units tall, and that it takes 25 units to get to that peak. The y-intercept for our first line is 0, because at x equals 0, y equals 0. We're just defining that as how we want to draw our triangle. The y-intercept for the second line we don't know. We're going to have to calculate it. But we do know that that y-intercept value is going to be equal to y equals mx plus b, where x equals 0 for our second function. We also know that our slope is negative, and because it's an isosceles triangle, it would be the same slope as our first line, so we can define m as a slope for both of the two lines. For the second line, m is negative because the line is going down. We can calculate b, which we'll call b2, simply by solving this equation for b. So b2 is going to equal y plus mx. To get there, what we did was we added mx to both sides of this equation, so y plus mx and mx plus negative mx plus b. Two mx's cancel each other out there, so we have b equals y plus mx. With that, we can then go and plug in the data point that we have. We know that y equals 0, where x equals 50, so we can use that data point to calculate b2. So here our slope is 500 divided by 25, our height divided by the distance it took to get there. And then b2 is our y value, 0, times our slope, times our x value of 50. So there we see that our slope is 20, and our y-intercept for our second line is 1,000. So now that we have that, we have to start to figure out how to put these two formulas together. It's not listed out here, but our formulas for the first line is y equals 20x plus 0. We can drop that part. And our second line is y equals negative 20x plus 1,000. Those are our two functions that we want to squish together into one. What we need to do is, where x equals 25, we need to invert the slope. We need it to go negative at that point, so it starts to go down. An easy way to do this is to figure out a way to be able to multiply our slope, m, by negative 1. So what we came up with to do that is to take 25 minus x, which tells us are we on the right side or the left side of the value of 25. Once we hit 25, 25 minus 25 will be 0. So if we take that value and divide it by itself, we'll always get 1. Anything divided by itself is always going to be 1. The problem is that if you take x greater than 25, then this term is going to be negative. So you'd have a negative divided by a negative, you'd get a positive. So what we're doing here is applying an absolute value function to the denominator. That will force it to be positive, and then the positive or negative state of our polarity will be driven by if x is greater than or less than 25. So to demonstrate this, we've got an example of our polarity function where x equals 20, so it'll be positive, and where x equals 30. We're also just going to go ahead and plot that as well. So here we can see where x equals 20, our polarity is 1. That's a positive slope. And where x equals 30, our polarity is negative 1. It's a negative slope. And then plotting it out, we can see that for x equals 0 to 25, our polarity value is going to be 1. And then at 25, it will drop down to negative 1, and it will stay there for the rest of the time. So we can multiply our slope by this polarity to make it positive or negative. And that's what we do in this function here. Here we're defining x as 200 values from 0 to 50. And then we're going to take those x values and plug them into our y function, which takes the polarity of x. It looks at, is it less than 25, in which case our polarity is 1, or is it greater than 25, in which case our polarity is negative 1. It's going to multiply that by m, so we'll get the appropriate slope, and then multiply our slope, polarized slope, by x. So now we can go ahead and plot that, and we should get a line that rises and then a line that falls. And we do. There's a little bit of a problem. That doesn't really look like a triangle, does it? However, we have a line that rises until x equals 25, and then from there it drops. But you'll notice that this line starts at negative 500, and this line ends at positive 500. The difference between these lines is 1,000. So this line's offset by 1,000, which, if we scroll back up, you'll see that our y-intercept for our second line is 1,000. So it's no coincidence that this is 1,000 off. And what we need to do is take this line and offset it by 1,000 so that the two lines meet up. So how are we going to do that? The way that I came up with to do it into a simple function was to take our offset and manipulate that so that if we are less than 25, we can use our polarity variable to take half of B2 and subtract it from the other half of B2 and get 0. If we're greater than 25, we can use our polarity to make half of B2 positive and then add that to the other half of B2, we get B2 back. Spend a little bit of time thinking through that. This was not all that easy to come up with. I'm sure there's actually a way to derive it, but I just thought through it. So if we look here, we know that we have our y function is our polarity of mx plus some b value. And the problem is b is going to change if x is less than 25 or greater than 25. So if we take b2, our y-intercept, and divide it in half, then we can subtract out half of that value and then add half of it back, and collectively that gives us 0. So if we're x less than 25, what this will do is give us a b value of 0. However, when x is greater than 25, our minus a negative polarity will cause half of b2 to be positive, which then we will add to the other half of b2 and get our original b2 value of 1,000. So it's a little bit of a math trick so that we can manipulate the b value depending on what side of 25 we're on. And then if you look through this, we'll just go through and do a little bit of a simplification to get down to our final formula. Because we're multiplying the polarity of x times both our slope term as well as our y-intercept term, we can pull that outside and wrap mx minus half of b2 in parentheses. So the polarity of x will get multiplied by both of these, and then we'll add back in half of b2 as well. So again, in effect, what's going to happen is when x is less than 25, half of b2 is going to be a negative term, which then added to half of b2 comes out to 0. When we're greater than 25, our polarity is negative, so half of b2 will become positive. This minus and negative becomes positive. We add it back to the other half of b2, and we get our b2 value back, 1,000. So by applying that little trick, we're able to offset our second line by 1,000 and draw our triangle.